So to sum all this up, basically anything that's destined for the internet that does not have a route is going to go out through the normal internet interface. Anything destined for these three subnets, 192.168.6.7 and .8, go through the VPN tunnel. And we can see this if we do let's do a trace route to google.com, let's say. And traceroute just shows us the path that the packet takes in order to reach its destination. Okay, so I can see to get to google.com, it's going out 172.16.1.1, which is the normal internet interface on this particular client machine. And these are all the different hops it takes out on the internet. Hops are just routers it's hitting on the internet in order to get to google.com. But the bottom line is it's going out the normal internet interface. Now I'm going to quit that. And now let's do a trace route for, let's say, dc01.iteavescorp.com and see the path it takes. Now you can see it went through 192.168.6.149. So it was sent through, if we look at our routing table, through to our routing remote access VPN server. And it reached its destination. So let's see the difference here with the trace route. If we go back, I'm going to disconnect our VPN real quick. And let's go to the properties of it. Let's go to networking, IP version 4. Go to Properties, Advanced, and check the box to use default gateway on remote network. By the way, when we uncheck this, disable class-based route addition, so that would not allow the additional routes added by our DHCP server if we checked that. Normally we would leave that unchecked though. Okay, so we're going to go back to sending everything through the tunnel, use default gateway on remote network, click OK. Click OK again. Alright, now let's go back and connect our VPN. Alright, and we can see if we do a route print now, we can take a look at our routing table. Again, now we got those two default gateways, but this is the one it's going to use because it has the lower metric. And it's going to be sent out our tunnel here, 192.168.6.142. So let's do a tracer to google.com and see the path it takes to get there. So you can see now it's going through our internal network, 192.168.6.1, or going through the VPN tunnel, I should say. Before, if we looked back at it, before it was going out our normal internet interface, 172.16.1.1. So if we scroll down here and see the latest one, again, it's different. And we can see, okay, yeah, it's going into my VPN server and going directly back out the external interface of my VPN server, and then this is all out on the internet. So that's how to configure split tunneling. And again, it's once we've got it set up, it's as simple as checking the box or not checking the box as far as if you want to use it or not. But understanding how it works can help us troubleshoot any issues a client might have if they're trying to access certain subnets in our network and maybe they're not able to, or if they're trying to access the internet while they're VPN'd in and they're not able to. So looking at the routing table on the client when the VPN's connected will tell us exactly what's going on. And just real quick, I do want to show that when we use split tunneling, what I'm going to do, I'm going to uncheck that box. Let's go ahead and click OK, and I'll disconnect and reconnect here. And let's go back. Let's do a route print so we can see our routing table again. So right now I'm using split tunneling and I've got these additional routes. I want to show that we do have access to these other subnets, and these routes do work for our, again, 192.168.7.0 and 8.0. Those are other subnets on my internal network. So if we look at our diagram, I've got, this is 192.168.7.0, and not on this diagram is 192.168.8.0, but it's another subnet on my internal network. So back to our client, and if we ping, let's ping 192.168.7.1, for example. And we may get the first one timeout, and then it'll work, so it's trying to figure out the path. So now let's do another one. I could ping another server that's on that subnet. And I could also ping 192.168.8.1. So now I have access to those subnets, but I'm still using split tunneling. So if I do a tracer to google.com or try to access any other subnet or any other internet resource, it's going to go out through my normal internet connection, which is 172.16.1.1. So if we're unable to access other subnets on our internal network and we're using split tunneling, just look at the routing table, and if you don't see the routes there, that's the problem. So we need to figure out why the routes aren't there. If we've just added the option 121 to our DHCP server, like this here on my DHCP server, then there's a good chance we might have to restart our or even reboot our VPN server. Because if we look at our address leases, what happens is the VPN server here actually goes out and grabs a bunch of leases. So it doesn't get those new options potentially if we had configured it. We actually configured it before we deployed our VPN server. But if we deploy our VPN server and then configure this DHCP option, again, there's a chance we might have to reboot that VPN server in order for that VPN server to pick up those DHCP options. And it should be noted too that there are other ways to add routes to a VPN client, in particular the Connection Manager Administration Kit. But DHCP is a really easy way to do it. If you'd like to learn more, please go to itdvds.com, where we teach all kinds of topics, and one membership gets you access to all of our training, including deploying a Windows Server 2016 VPN and managing VPN clients, which includes deploying a public key infrastructure, all the steps to that, the different steps and certificates necessary to get the different tunneling protocols to work, and creating a VPN server, deploying VPN client certificates, and deploying VPN client connections with PowerShell, Connection Manager Administration Kit, Group Policy, and System Center Configuration Manager. We also have step-by-step training on deploying a highly available VPN for remote clients with Windows Server 2016, and deploying a highly available Microsoft Direct Access for remote clients with Windows Server 2016. And one membership gets you access to all of our training.